Okay, so here we are with review of log functions, and I've picked a question from exercise 6D. It's actually question 7, which it's quite an interesting question when we look at the transformation of these functions, the log function and the exponential function. So the question is saying what transformation maps y to the y equals e to the power of x, so the exponential, to the log function y equals log base ex. And how can this transformation be used to find the gradient? Okay, the gradient of the log function and its x-intercept. So these are the key questions that we need to answer. Now, keep it in mind that you've already taken down the notes from one of the slides and the key ideas about these two functions, particularly the fact that the exponential function is the reflection of the y equals log base e function, and it's reflected on y equals x, which is your straight line that goes right through the origin. Okay, so keeping that in mind, if I was to just quickly, like so I've got this piece of paper here, right? So I've already graphed y equals e to the power of x. So, and because I know it's going to be reflected on this line y equals x, I've just folded it here. Okay, so there it is. Now if I turn it and quickly sketch the actual, what I can see the reflection here, let me see if this works. Maybe I should use another colored pen. So just as I put it here, you probably can't see it, but if I just draw it here on the other side, I open that up and you can now see where the reflection has occurred, right? You can see it's over here. And we know that this is my y equals ln x, so the log function, right? And we end up with a reflection and I'll just quickly draw y equals x so that you can see that as well. So this is my y equals x, straight line, right? And that's what we end up with, right? So keeping those things in mind, we can answer this, the first part of this question. It says, how can, what transformation maps the exponential to the log function? And well, can you tell me? Everybody should know now, right? So the answer should be, there's a reflection, okay, in what line? Y equals x, right? And this is the transformation. So this is the transformation that maps the exponential to y equals log base ex, the log function. All right, so that should be the answer for the first one. So then, and you probably knew that already from the notes on the slides. Now the second part of this question says, how can this transformation be used to find the gradient? Now, if you think about this, let's consider, so this is the next part, consider y equals e to the power of x. Now, when we're asked to find the gradient, remember, the gradient is also talking about the first derivative. So if I was to find the derivative of this function, which is that. And because on the diagram, I should have, I can just sketch it over here. Okay. Here is y equals e to the power of x, and we know it cuts the y-axis at 0, 1. So when x equals 0, I can find the gradient. So when x equals 0, dy dx is equal to e to the power of 0, which is equal to 1. All right. Now remember, my dy dx is the gradient of a tangent at a particular point. In this case, x equals 0. So I have found at x equals 0, I have found a tangent here. Okay, this is where n is equal to 1. Okay, so now if you think about this, we also need to know that the reflection, so that y equals x, so I'll just quickly draw this y equals x over here. Y equals x reflects the line with the gradient of 1 to lines of gradient of 1. Okay, so that's something that we need to remember. So y equals x reflects lines with gradient of 1 to lines of gradient of 1. So what does it mean? That means that the reflection of the exponential function, which happens over here somewhere, so somewhere over here, and we know that this cuts the x-axis at 1, we know that its reflection will also have a gradient of 1, right? So therefore, the function y equals log base ex will also have a gradient of 1. Okay, so that's part A. Now part B and C are asking you to state the transformation that maps these two functions. So part B, I'll just do it over here. So for part B, what transformation takes place? Maps y equals log base ex, right, to y equals log base e minus x. And how can this transformation also be interpreted as a dilation? Okay, let's just think about this. This is all about graphing. And I know this is part B and C, because part C is asking you to graph. So for part B, we know what this function is and how to graph it, how to sketch it. So we know it goes this way. So that's a 1. Okay, and the transformation that'll take place from this to negative x, if you remember from year 11 work, right? It's the reflection in the y-axis. Right? So this is y equals log base ex, and y equals log base e minus x. It's actually the reflection in the x-axis. So over here, this is my reflection, okay? And therefore, if it's a reflection, the distance between the origin and this point must be the same as the distance between the origin and -1. So I end up with that. And I guess a couple of other things that we could also state, that there is another important point here. And just so that you know for future reference, okay, this point here is 1 plus 1, right? So we have that other important point. So reflection in the y-axis maps this function to that function. And it also has a horizontal dilation with a factor of -1, right? So, which is also, this is some of the stuff in year 11 that you would have looked at, which is also horizontal dilation with a factor of -1. Okay, and that takes care of that question.